Yes, it is a small number. Okay, small number. Okay, that's the understanding. See, it is a clear cut understanding or the clear cut learning about which I am talking now. See, student, 6 if small, you are considering I understand. 60, 602, or 6022, 6000. So, what do you think? 6000 is a small or large number? Okay, Alia is saying it is a large number. 60,000, large number. 6 lakh, large number. 60 lakh means 6 million, large number. See, 6 million means 6 into 10 raised to 6. And what is Avogadro's number? Yes, please type that Avogadro's number. Yes, Kartika, 6.022 into 10 raised to 23. Yes. So 10 raised to 6 means million, and you are seeing that's a 60 lakh. 6 million is a large number. To that number, you are saying it is a large number, but to Avogadro's number, to mole, you are saying it's a small number. It's a surprising. How could you dare to say that Avogadro's number, a mole, is a small number? Are you following what I'm saying? Yes, okay, good. It means your approach to study was a blind approach. You have to visualize the thing. You have to imagine the things properly. You have to correlate the things. You have to compare the things. Then cognizance or understanding of chemistry will be more or proper, and then you could apply the concepts. So now onwards, at least you should be alert enough to think logically. Okay, so now conclusion is the mole, that's Avogadro's number, is a considerably large number. So it's a bunch of, set of, group of large number of atoms, ions, or molecules, or electrons, whatever the entity that we are considering. I had given you for homework 3 molecules to find their molecular weight and one reaction to find which is a limiting reagent. That homework is given to you. Do you have any question to complete that homework? Any problem to complete that homework? Please reply fastly. Kartika said no. What about others? Okay, Poonam said no. Yes, Ismail, are you there?
Hello.
Sir,
Yes, Ismail.
That homework should be completed in how many pages? This?
Pages is not likewise. You have to find the answer, clear cut
Oh,
answer with substitution, molecular weight of these 3 compounds, and that in 1 page you can complete all if you write properly. Otherwise, maximum 2 pages. Number of pages is not restriction. Proper answer is important there.
one word?
1 word, how can you answer? In 1 word, you
No.
can't answer. You have to substitute the values and you have to find molecular weight. You have to show the detailed calculations. Descriptive answer I want.
Okay, sir.
Yes, Rupashri, you
sir,
were saying something. Yes, say.
find the number C2H2 needed the times O2. तर मग what काय करायचंय त्याचं म्हणजे नक्की? म्हणजे डिफरन्स
See,
काढायचे ना?
no. See, times, number of times when it comes, then always multiplication. Number of times. Difference means subtraction. These are the mathematical words. How many times the cost is larger means number of times. Means how many times I have to multiply, then I can get that cost. How many times cost is less, then I have to divide. Are you getting? 2000 and 10,000, these 2 numbers are there. One mobile is there for 10,000, one mobile is there for 2,000. So compared to 10,000, 2,000 is less. So how many times it is less? It is less 5 times. But what is the difference? Difference is 8,000 rupees. If I compare with this 2,000, how many times that number, that's the other mobile cost, is larger, then you will say 5 times. So 5 times smaller with respect to 10,000. That's the number 2,000. That's this mobile. And other is 2,000 and I'm comparing with 10,000. So 10,000 is 5 times larger. So if it is a larger, then you multiply. If it is a smaller, then you divide. Rupashri, are you getting this comparison?
Yes, sir.
Okay, while preparing tea, suppose if you are using 1 teaspoon of tea powder and double quantity of sugar, 2 teaspoon. So how many times more you are adding? Don't say one, it's a double. So for 1 cup, that much quantity. For 2 cups, you will multiply that, the multiplication to tea quantity, multiplication to sugar quantity, that you will do. So these are the recipes where we use them in proportion, not subtraction. Proportion means multiplication or division. In reactions also, these recipes are there, they are combining, they remains in proportion, they remains in multiple. If you want to prepare water, in water, formula is H2O. How many hydrogens are there? 2. How many oxygen? 1. So who is more hydrogen? How many times? 2 times. Who is less oxygen? How many times? 2 times. But when less I say, I'm going to divide. When I say more, I'm going to multiply. So whatever the quantity of oxygen I take, suppose if I take 1 liter of oxygen, I will take 2 liters of hydrogen. If I take 5 liters of oxygen, I will take 10 liters of hydrogen. Reverse way. If I take 20 liters of hydrogen, half quantity, divide by 2, 10 liters of oxygen. So where is subtraction? In chemistry, here reactants are combining with respect to proportion. If you scored 20 marks out of 30, then how many marks out of 60? Multiple times, multiples. You will not do subtraction there. Here 30 plus 60. So here 20 plus 30 means 30 plus 30 means 60. So 20 plus 30, 50 you will not do. You will convert the marks in proportion. So proportion means multiplication or division. It is a basic. Rupashri, are you following what I'm saying?
Yes, sir.
Other students, are you getting the point what Rupashri has asked and that answered? Good. Here, you can find number of moles of oxygen needed, number of moles of acetylene needed, because acetylene and oxygen are the reactants, whatever the problem that are given to you. If you find number of moles of oxygen needed, number of moles of acetylene needed is a different task, or number of moles you are with. But in reaction, if you see the reaction, 2 acetylene are there, 2 acetylene molecules. You take molecules, you take moles, you take metric ton that I discussed previously. But multiplication will be there. Let you to the smaller scale or let you with the larger scale. Let you prepare this, suppose you are preparing tea, let you prepare tea in terms of cup or let you prepare tea in terms of bucket. Ratio will remain same. Proportion will remain same. Likewise, here 2 acetylene molecules you are taking. So quantity 2. Number 2 you have to consider. And how many oxygen? Please help me. How many oxygens? How many molecules of oxygens are there in reaction? Reaction is a molecular reaction. Yes, 5. So think number 5. Previous number is 2 and now number is 5. So proportion. Who is more? Oxygen is more or acetylene is more? In the reaction point of view, from reaction point of view, oxygen is more. So it's a multiple. So oxygen, how many times is more? How many times is more compared to acetylene? From that reaction, you will find it is 2.5 times or 5.5 times. It is a proportion. So understand, whatever the unit of measurement you take, whatever the quantity of acetylene you are with, oxygen should be 2.5 times. Suppose if acetylene is of only 2 quantity may be mole, measurement may be mole, measurement may be liter, measurement may be gram, measurement may be ton. With that measurement only, multiple. How many times more you want oxygen? 2.5 times more. So what you did there, you found moles of acetylene. In that homework, moles of acetylene you have found. How much acetylene you were with? How much gram?
10 gram.
10 gram. It's a weight. 10 gram. But I want in terms of mole. Mole is a proper unit of measurement. Only in terms of gram we can't perform the reaction. Don't think that 10 gram of acetylene taken. So how much oxygen you want? Oxygen you want 2.5 times. So what is 2.5 times of 10? What is 2.5 times of 10? 10 into 2 times means into. Means if it is more. 10 into 2.5, what's the answer? Yes, 25. So don't think that 10 gram of acetylene taken, for that 25 gram of oxygen needed. It is a not understanding of chemistry, because chemistry deals with atoms, ions and molecules. So to measure them, we are taking help of mole. Therefore, we have to calculate number of moles there. Otherwise, directly we would have went through the. So is it the need of calculation of mole clear to you? Okay, good, good, good. So number of moles for acetylene you calculated, and just now somebody has given the answer. How you found number of moles? Quantity, that's in terms of gram, divided by molecular weight. How much quantity? That's a 10 gram. What is the molecular weight? Yes, what is the molecular weight? 26. 10 gram divided by 26 gram. Molecular weight in terms of gram. Molecular weight 26. It is no unit, but we have taken in terms of gram to find number of moles. So 10 divided by 26, we are getting answer 0.38. That's a mole. Number of moles you are getting. Just simple, it's a number. 0.38 mole. It is a quantity available. Of whom? Acetylene. About oxygen, what is the weight of oxygen available with you? No. What is available with you in reaction? 60 gram. 60 gram. Unit is important. Yes, Swapnali, Kartika, right? 60 gram. And what is the molecular weight of oxygen? What is the molecular weight of oxygen? Yes, 32. Not 1.8. Okay, well, that you are showing ratio. 32. Molecular weight is no unit, but we are taking in terms of gram. So 60 gram divided by 32 gram. Gram and gram will cancel. That substitution also I want. Proper substitution and proper calculation. Answer is coming 1.8 mole. So how much quantity of oxygen available? Talk in terms of mole. It's a 1.8. How much quantity of acetylene available? 0.3. Yes, 0.3. How much? Yes, 0.38. 0.38. So here don't compare likewise. Oxygen is more and acetylene is less. See the reaction. Reaction tells that for 2 acetylene, we want 8 oxygen. Sorry, 5 oxygen. Means oxygen should be how many times more? 2.5 times more. Now let us consider reference as a acetylene. So take acetylene as a reference. 0.38 moles are there. So what is the 2.5 times of 0.38? Means 0.38 into 2.5. What is answer? 0.38 into 2.5. Answer is 0.95. Yes, Rupashri, Kartika, right? So you want 0.95. But how much oxygen you are with? How much oxygen, how many moles of oxygen you are with? 1.8. You have 1.8 and you need 0.95. So oxygen available is more or it is less? Whatever the oxygen quantity you are with, is a more quantity or less quantity? It is more. Okay, who is saying less? Kartika, what's the problem? You have 1.8. Okay, Kartika mistakenly said. So it is what more available. So it is not limiting. Who is limiting then? Acetylene is limiting. Acetylene quantity is less available for us. Oxygen is more available. So who is a limiting reagent? Acetylene is a limiting reagent. Likewise, if you calculate, then proportion concept you will remember. And here what you are doing, you are visualizing. Acetylene is one chemical, oxygen is other chemical. For measurement, we are using scientific chemical term, that's a mole. And number of moles of oxygen needed are 2.5 times larger or more than that of acetylene. So acetylene mole we calculated and 2.5 times that we did, it is coming more. Therefore, we can say oxygen is excess. If it is coming exactly, so proper stoichiometric quantity available. If oxygen quantity available is less and quantity coming in calculation is more, it means oxygen is limiting. Like as limiting reagent, we can find out. So is the concept clear to everyone now? To be able to imagine properly? So today let us discuss again, it's the basic part. I'm going to improve the basic, let you understand the properly first. I'm going to show you one reaction. Yes, could you read that reaction? Is it possible for you, or shall I magnify that? Yes, now you talk because I am presenting here. I could not pay the attention towards your chart.
Magnify, sir.
Okay, I have to magnify. Just wait, just wait. I am learning to magnify. Just wait, let me see. I think it is magnifying. Magnified. Could you able to read now reaction?
Yes, sir.
Yes, sir.
Yes. Yesterday's reaction only 2C2H4 means acetylene in gaseous form, 5O2 in gaseous form. Those results 4CO2 gaseous form and water in liquid form. So temperature of reaction is what? Low, therefore it's liquid form. If temperature would have been higher than 100 degrees centigrade, then H2 also would have been the gaseous form. Here the industrialists want to manufacture carbon dioxide to fill in the cylinder, and he uses a chemical, that's acetylene and oxygen, and it's performing this reaction. So what is the situation is a problem. The chemist has only 6 grams of acetylene, listen carefully, and unlimited supply of oxygen. I repeat, he has only 6 grams of acetylene. And how much oxygen? Unlimited, abundant oxygen, more quantity of oxygen is available. And what he wants, he desires to produce as much CO2 as possible. And this is a reaction. If she or he, you can consider, uses the equation below, how much oxygen should she or he add to the reaction? So they have given quantity of acetylene. For this reaction, considering proper stoichiometry, how much oxygen is to add? That is a question. How can you answer that? I give a hint to you. Reaction is known to you. First find in this 6 gram our chemical unit in terms of that acetylene. What is our mole? In that 6 gram, how many acetylene are there? Don't consider now balancing of this reaction at this moment. Just calculate how many moles of acetylene are available. How will you find that? Yes, will you help me? Unmute and talk. How to find number of moles?
Molecular.
Yes. So amount is 6 gram. And what is the molecular weight? Just you have calculated, it is 26. So just somebody do calculation. 6 divided by 26. Okay, I open the calculator. I want to open calculator. Yes. 6 divided by 26. So answer is 0.231. Why I'm considering 1? Because 7 is there, is more than 5. So its effect I consider here as a 1. If you are considering up to 4 digit, then what you should consider, how should read that number? 0.2308. Why 8? Because after 7, whichever number is there, it is more than 5. Likewise, we have to read. So number of moles, if I consider the only 3 digit, then 0.231. These many moles are there. I want to find quantity of oxygen that I have to take. Now answer for my question. How many times oxygen you need to take compared to this acetylene? Compared to acetylene?
2.5.
Right, 2.5 times. How many moles are there of the acetylene? 0.231. Into how many I should do so that I will get the moles of oxygen? 0.231 into how many times? I want the moles of oxygen. 2.5, right? 2.5. So what's answer? 0.5775, or you can consider 0.578. It's a making even rule. So those many moles of oxygen I want. Up to your concept clear?
Yes,
Unmute and talk.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, from voice, no noise or no sound.
Yes, sir.
Okay. 0.5775 moles of oxygen that we want. So this 0.5775 moles of oxygen means how much oxygen in terms of weight that you have to find out. What is the formula of mole? Weight divided by molecular weight. Molecular weight is known to you. Now moles are known to you. You have to find weight of oxygen. Yes. Will anybody calculate and will explain how to find number of moles. Perform calculation and give me answer. Number weight of oxygen necessary. How much oxygen we need? If you have calculator, then till now you should calculate actually.
0.5.
0.5 what?
3.6
3.6 what? Gram, kilogram. See, always if you need, you have
gram.
to mention it. 3.6 gram. How to calculate? Will anybody help me? How to calculate that? Yes. If no, then say no. I am wasting
Repeat the
time. Likewise, I am finding. Yes.
Repeat
I
question.
could not hear. Talk loudly so that everybody will understand.
Sir, repeat question.
The question repeat, sir.
Okay. Question is, you have calculated number of moles. This many moles of oxygen is necessary. Moles. I want that oxygen in terms of weight, in terms of gram. So you do calculation like I said. So if you have did calculation, they answered. I want explanation for that. Explain how that number came. How much quantity of oxygen in terms of weight necessary? Give me answer and explanation. How much oxygen is necessary? That's a question. In this is how much oxygen should she add in the reaction? It's a question. Explain that. Partly I explained. Number of moles of acetylene I calculated. Number of moles of oxygen needed I explained. I want now that's how much oxygen. That's a weight. Can you answer? If no, then
160
say
gram.
no. Unmute and talk.
160 gram.
How?
160 grams.
How?
For 1 mole 32 gram. So 5 moles
5
160.
moles?
32 into 5.
32 into 0.578, 18.4.
Wait. It's two different things I am getting there. One by one, let me consider. Who is saying 180? No, to that I let me calculate. 5 into 32, somebody is saying no. Who is saying that?
Yes, sir.
Yes. See, you are going through reaction. Who is talking, Alia?
Yes, sir.
Chai? Okay. See, you are going through the reaction. Reaction is a molecular reaction. In this reaction, how many moles to be taken, that is not informed. Only proportion is explained there. But you are considering that 1 mole, 5 moles, 5 number is not for 5 moles. It can be mole, it can be molecule, it can be ton, it can be kilo, it can be any unit of measurement.
Only
But you are
32.
yes, are you getting this, Alia?
Yes, sir.
Therefore, what we did till now, we calculated number of moles of oxygen needed, and on calculator I have shown you these many moles of oxygen needed. These many moles of oxygen means how much weight? That's a simple question. Yes, can anybody answer? Some other student was answering. I want that answer now.
32.
These many moles of oxygen means how much weight? How much quantity that I have to add? Because this mole is
0.018
practically not
gram.
measurable. How?
0.018 gram.
How that answer? 0.018 that answers found. How that answer came? Explanation.
0.5775 divided by 32 is equal to 0.018.
0. Why divided by 32?
Oxygen.
Why divided by 32? Okay. Now everybody write down the formula in the book. Everybody write the formula in the book. Number of moles means N. Number of moles N is equal to, write down the formula, is equal to W divided by molecular weight. MW you can consider, or capital M you can consider. Is that formula clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. This is a formula, and with this formula only you have to answer. Now what is the situation? Till now what? I was giving weight. W I was giving, and you were calculating moles by formula weight divided by molecular weight. But now what is the situation? You know the number of moles, you know the value of N, and that value of N is this one, 0.5775 is a value of N. Value of molecular weight, it is not changing, it is 32, that you know. In terms of gram, we have to express that now, understand. And what is the value of W? That you have to find out. So W is equal to, write down formula. W is equal to,
18.4.
what is the formula? W is equal to
Number of moles into molar mass.
Number of moles into molecular
molecular
weight.
weight. Yes, molar,
Number of
yes.
moles
Or
into
molar mass
molecular
you can
weight.
consider. Right, molar mass is a proper word. So N into MW. Is it clear? So properly suppose if you arrange the equation, properly suppose if you arrange the formula and actually you work, no, then it is solvable. But your method is you are making this chemistry or mathematics difficult because you want to read and you want to remember. It is difficult way of learning the mathematics or the chemistry. It is learned by application. Now what you did, you wrote that formula and you applied that your simple mathematics and you could get the answer. Yes, what is the answer? 0.775 into 32.
18.48.
18.4.
Yes,
18
18.48. See, 8 is a large number. So don't neglect that 8. You either represent 18.5 or you can say 18.48. This much gram is what necessary for the reaction. Is this discussion clear? Are you following what I am saying? Here, they
Yes,
did the
sir.
approximation. Yes.
Yes, sir.
Now, one more formula that I am giving, and this formula is important this year also. It is necessary. Whatever I discussed now, number of moles, limiting reagent, that is just the basic point of view in order to bring you on the track. Okay. Now I am going to inform you this formula, and in case if you have any doubt that you can what the ask. Then we are coming to this molarity. It is also important this year. Here percent composition, percent mass is one way of representation, percent mass. So percent mass means what? Mass of solute divided by mass of solution into 100. You can write down this formula in your book. Percent mass is equal to mass of solute divided by mass of solution into 100. Now I discuss the term, each term now. Percent is a relative term. Smaller, larger, relative term. I said no, number 6 is a small value or high value. Relatively, general point of view, we are considering it as small. So, small. But if you compare this 6 with respect to 0.0000000 many zeros 6, compared to that, this 6 is very larger. So don't consider 6 is small. Nothing is so small, nothing is so large. More than so relatively, relativity when remains. Compared to 10, 6 is smaller. Compared to 1, 6 is larger. Compared to 1 million, 1 lakh is smaller. But compared to 1,000, 1 lakh is larger. Compared to billion, million is smaller. But compared to 1,000, it is larger. Are you getting the point what I'm saying? Please talk.
Yes, sir.
Yes, sir.
Yes, sir.
So relatively we have to express, and for relative expression, one concentration or one term that we use, that's a percentage. Relatively, comparison becomes what? Easy. One scored 90%, one scored 80%. Comparison becomes what? Easy. It may possible who scored 90%, his maximum marks are only 500, and who scored 80%, whose maximum marks are 1,000. Different universities may be there, different pattern may be there, different marks for paper may be there. So pattern changes. Pattern changes, outcome will change, but percentage will not change. Percentage concept will remain same. So for comparison purpose, we compare by means of percentage, relative term it is. So we compare it with what? The other. So when we say percentage, it can be aggregate percentage or it can be percentage in that particular paper. But anyhow, by percentage, you can compare. Average percentage are more than the marks of this paper or marks are less. That comparison we can do. So how much you have scored, good score in that paper you did compared to others or not, that you can do by means of percent calculation. So percentage helps us for comparison. Therefore, we are studying this unit, that's a percent unit. But percent by means of what? What's the way of measurement? Because chemicals, we can measure in terms of volume. Chemicals, we can measure in terms of weight, means in terms of gram. So what is the weight of measurement? What is the way of measurement? In terms of volume, percentage may differ, and in terms of mass, percentage may differ. For example, the cotton, the deflagrated cotton, separated cotton, or You might be knowing the Budde ke bal, the for eating in festivals or in jatras or so, it remains. Yes, do you know that?
Yes, sir.
Yes. So that you can say cotton likewise. So cotton is lighter, that we say. Comparison point of view that we are talking about. So its size remains larger, but weight point of view, it is a small weight. Weight is less. And other quantity if I take, say sugar or salt. So quantity of sugar or quantity of salt may be smaller, but weight can be larger. Relatively, I'm talking about. Suppose whatever the size of that cotton is there, that much size I'm talking about, that much sized sugar if I take or salt if I take, the weight will be larger. If I consider weight as a constant, then quantity of sugar will be less compared. Quantity in the sense the size of the sugar will be less compared to the size of the cotton. So with which we compare? By weight we compare or by mass we compare? Or sorry, by weight we compare or by volume we compare? That is what important. So here we are learning comparison by means of mass. Percent is for comparison purpose. Percent by means of mass. So how to find that? Where in solution, let it be any solid solute solution or liquid solute solution, but here our way of measurement is weight. Answer for my question: solution means what? Solution is made from which things?
Solute
How
and
solution is
solvent.
obtained?
Solute and
Yes,
solvent.
Solute and solvent.
Solute and solvent.
right, solute and solvent. Solute and solvent. So if I consider any solution, answer for my question, quantity of solute will be less or more compared to solution?
Less.
Less.
Good, good. Answer for my next question. Quantity of solvent is more or less compared to solution?
Less.
Less.
Yes, it is
Less.
also less because solution is addition, no, of solvent and what the solute. But quantity of solute can be less than the solvent or can be more than the solvent. How? Suppose a percentage is 20%, 20% of solute mass. Then answer for my question in terms of mass. Solvent is more or solute is more? If question not clear, ask me to repeat.
Solvent is more.
Yes, solvent is 80%, solvent is more. If I consider 50% mass of solute, then who is more, solvent or solute?
Equal.
Equal.
Right, both are equal. Very good. Who has answered? Yes, who has answered? That's my question. Okay, now I come on the screen. Who was talking? Swapnali, have you answered? Or any other student?
Rupashri and Amisha, sir.
Amisha answered. Okay. Okay, good, good. Equal, both are equal. But if I consider 80% of solute, then solute will be more. So that's a relativity that we can find by means of the percent of mass. And what is the formula? Mass of solute or weight of solute divided by mass of solution. Solution is a combination, solution mixture into 100. So total into 100, that is a percentage. But if using for comparison about percentage, will solve few problems. Today I discuss calculation of weight and one formula I told you, and that formula is regarding percentage mass. Is discussion clear?
Yes, sir.
Yes. So student, write down a homework. What is the homework for you? Write down the homework. Already you are with this reaction. Which reaction? Acetylene reacts with oxygen to form CO2 plus which? Write this reaction. And problem is, write down the problem, the same. Chemist has unlimited quantity of acetylene, C2H2, unlimited acetylene, and 100 grams of oxygen. 100 grams of oxygen. How much acetylene That's he or she has to use to produce maximum CO2. Is that homework problem clear?
Sir, once again repeat.
From when? Right from beginning?
No, sir.
Yes. I asked you first to write this reaction. Then I said chemist has unlimited amount of acetylene and 100 grams of oxygen. Then what you have to find out? How much acetylene should he or she add to the reaction so that maximum CO2 will be produced? Is it clear?
Yes, sir.
Yes, sir.
Shall I repeat again?
No, sir.
Okay, so it is a homework for you. Today's homework. Yes, plus write down the formula of percent mass. It's a homework. It's a notes of percent mass. The parts per 100. ppm is parts per million. Here only parts per 100 we are getting. So these two questions are there for you as a homework. One, that's a problem you have to solve, and second, percent mass that you have to find out. Yes. Is it clear to everyone?
Yes, sir.
Yes, sir.
If you have any doubt, any
Yes, sir.
question, you can ask.
No, sir.
If no question, say no question. Yes, Amisha.
No, sir.
Okay. Other students should reply. You can reply in chat box.
No, sir.
Okay. Okay. Good.
No, sir. No, sir.
No, sir.
Good. Okay. So see, yesterday and today, whatever I discussed, it is just the basic. It is necessary for you. Then you will prepare a strong base and you can want to build your bungalow of concept of chemistry. What do you think? Whatever I discussed, was it essential for you or not? It was needed for you or not? If you are thinking it's a wastage of time, then you can say, I'll move next. We have sufficient time. Don't worry about that. Needed. Okay. Okay. But now I suggest you listen carefully. Don't go on only reading or memorization. You have to practice. As you practice, no, believe me, at the beginning you will find it's a troublesome, problematic. But once you practice and once you get habituated, you will enjoy and you will learn to learn. And that's my motto actually, to teach the student how to learn. Yes. Okay. So if you have no question, then what I do, I stop the recording and I suggest quit now. Lecture is over.